Well, hello again. Back for another math lesson I see. Today we're going to do a little bit more partial quotient division. So if you want some review on this, you can take a look at the other video that we had for partial quotient division. But hopefully today's will help you also. So partial quotient division is just a strategy of doing dividing, which is the opposite of multiplication. Sometimes I'm going to talk about finding the area because the area is multiplication. Remember, we're doing length times width will get us area. I'll also talk about basic fact and extended facts. A basic fact is like 2 times 7 equals 14. An extended fact of that would be 20 times 7 would be 140, equals 140. So keep some of those in mind as we go into our lesson. All right, so the problem to warm up with is Kate needs to buy 112 bottles of fancy water for a birthday party. Bottles come in packs of 4. How many packs should she buy? Can you show your thinking with number models and maybe a diagram? So if you want to try this on your own, you can pause the video now. If you want some support with it, let's do it together. Or welcome back after pausing. Okay, so what do we know? We know Kate's going to have, I'm assuming, a birthday party. Hopefully she's doing it in a socially distant manner. We know that she wants 112 bottles of water for a party, and that bottles come in packs of 4. What it's asking is how many packs should she buy? So how many of these packs of 4 does she need? So I've already started to set this up looking like partial quotients. So we have an area, or you can think of it like an array. Inside the array are going to be 112 bottles. We have those 112 bottles. How do we want to package those up? We want to pack them up into packs of 4. Okay, so we have groups of 4. So how many groups of 4 can give us 112? So that's what we're trying to figure out with how many packs should she buy. So I'm going to just keep that there to remind us that that's what we're going for. But since we're going to do partial quotients, I'm going to leave this open for right now. So we need to find a way to get close to 112 bottles and just start like packaging them up, or just like start like running them across the checkout in the self-checkout aisle. So I could do 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4 forever until we get to 112. But that would take a long time. So I'm going to try to think about some basic facts. 4 times something. So I like my tens. So I'm going to say 4 times 10. I should change this. Pay no attention to the child crying in the background. Hopefully someone else will take care of that for right now. Okay. So if I have 10 packs of 4 bottles, that would give me 40 bottles. Okay, that's not bad, but that's not 112. So what I need to do then is think about that as part of the answer. So I have 40 bottles here in 10 packs, but I need to get to 112. So now I can do that again. I can say I have another 40 bottles. How did I get 40 more bottles? I had to get 10 more packs. So I'm at 80 bottles. 80, 90, 100, 110, 112. So now I still have 32 bottles that I need left. Can I do that with 4s. Well, I can't do a 10. So what if I did a 5? I get 5 more packs. 4 times 5 would be 20 bottles. Okay, not bad. Still not exactly what I'm looking for, but I'm getting closer. So 20 now. So 40, 80, 100. We need 112. So now, how many bottles do I have left? Not 20, but 12 bottles left. Can I get 4 packs to get me 4 bottles? I can do 4, 8, 9, 10, 11, 12. I can. I just need to buy 3 packs. So I have 40, 80, 100, 112 bottles. All right, well, that worked pretty well. So now, how many packs do I need? I need 10 packs, 20 packs, 25, 26, 27, 28 packs. So I needed, or Kate needed, 28 packs of fancy water. That's one way to solve it. The reason I like partial quotients is because you can solve it a lot of different ways and still get to 28 packs. For example, what if I knew that 4 times 10 was 40, but that 40 wasn't really close to 112? So then I instead, in my head, I just wanted to do 20 packs. Go away, go away. Delete. If I have 20 packs, I know a basic fact, 4 times 2 is 8. 4 times 20 would be 80 bottles. 80 bottles. Now I have 20 packs. Now I have 20, 80, I can get to 100. 80 and 20 is 100. That's 4 times 5 is still 20. 4 times 3 is still 12. So it's still 25, 26, 28 packs. It's still the correct answer. I could still do it another way, and you don't have to solve it all these different ways. I'm just showing you that partial quotients is much friendlier than anything that your family probably learned growing up. So you could also solve this even more efficiently if I thought about it like, okay, I had 80, I needed to get to 112, 80, 90, 100, 110. So I still had 32. Not 320, hang on. Slow down, give me a second. So 4 times what will give me 32? Let's see, 4 times 5 is 20, so I say well, 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. I have 80 in my 32 to get my 112. So I have 28 packs. So using the area model, using partial quotients, I was able to get 28 packs of waters a bunch of different ways. And you can choose the way that you want to do it, depending on how well you know your multiplication facts. If you want to do 10s and 5s, that will always work. It might take a couple more steps, but if it's faster for you to do those, that's great. If you know some of your 7s, 8s, 9s, then you can use some of those facts that you know too. So another example of this Oliver bought 162 stickers to put in gift bags. He wants each bag to have 6 stickers. How many bags will he need? So we're going to set this up the same way. If you want to pause it right now, you can pause it so you can think about it, but it's going to be the same kind of setup. What do we know? Oliver has 162 stickers. What else do we know? He wants each bag to have 6 stickers. That's not how you spell stickers. 6 stickers. What we're trying to find out is, we know the length is 6. How long is this? So again, lots of different ways to solve this. I will solve it one way, but you could solve it a whole variety of ways. So, you know how I like my 10s. So let's do some 10s. 10 bags. If he has 10 bags, how many stickers will that give him? 60 stickers. All right. If he has 10 more bags, then he can have 60 more stickers. So we know 60 and 60, we know he has now 120 stickers. But he needs 162 stickers. Can I do another 10 bags? 60, 120, 130, 140, 150, 160. I can't do another 10. Could I do 5? 6 times 5 is 30. Let's see, 120, 130, 140, 150. I can do 5. Okay? 5 bags. 5 bags would be 30 stickers. Okay. Just gonna slide this over so I can make the line a little closer. So how many stickers do I have? I have 60, 120, 150 stickers. 150 to 162 stickers, and that means I have 12 more stickers. How many bags would that be? 2 more bags. So now how many bags will he need total? 10, 20, 5, 27 bags. That's it. So that's just one strategy to solve this. You could have done 6 times 20. You could have done 6 times 1, 6 times 1, 6 times 1, 6 times 1. You can do it any number of ways. So we're using bigger numbers. We're dividing bigger numbers now, which means this is going to take a little bit more work, a little more thinking. I strongly encourage you to use paper, draw it out. If you draw it out one way and you're not sure, draw it a different way to see if that can help you. You don't have to get it right the first time. Please reach out, email me, email Ms. Roth, talk to your family, have them get in touch with me. This is a big deal. These are challenging problems, but I know you can give it a try. And I know that you will be able to get this. I know you can do it. All right, good luck.